Well, yeah. So we're supposed to get a huge dump of snow tomorrow afternoon. Literally, as we are escaping Vancouver Island, there's going to be a huge dump of snow coming to like Victoria Airport. Like I can just imagine, it's going to be like some horrible blizzard coming in our airplane. It's going to be like, come on,
I
you can.
hope they have de-icers.
Oh yeah. Well, it doesn't get that cold, right? So it's just going to be like just barely cold enough for snow to come down, and then we'll just be like barreling down the runway with this blizzard chasing us off the island, and then
They still have to de-ice to make sure you have the chemical in the aircraft so that when you hit altitude, it doesn't freeze. 'Cause that causes
right, right,
planes to
right.
fall out of the sky.
Yeah, no, we don't want that. Well, we're gonna be until we get to Costa Rica anyway, and then. And man, I gotta admit, so we're off to Costa Rica. We're gonna be there in Friday. We sort of fly out Thursday afternoon. We arrive at Costa Rica Friday morning. Then we fly down to this tiny little town in Costa Rica, and then we spend 10 days in the jungle. Yeah. Now this is this is the wife's vacation. And I am just going to be there to attract the mosquitoes and malaria and pit
Do they have
vipers.
malaria in Costa
Oh
Rica?
yeah, oh yeah, yeah. And typhoid. Yeah, Zika.
I knew they had Zika.
Yeah. No, pit vipers, banana spiders. Pit vipers apparently they're the cause of most people in Costa Rica's death by snakes. Is this one snake? It's just awful. Um, so and the crazy part as well is next week. The temperature is going to get down to minus 15 centigrade, which I'm sure for a lot of people like that's nothing. But yeah, we're going to be at minus 15 Celsius here, so we'll be gone. But that is the coldest that I've ever experienced in British Columbia, where I live. So, like once as a child, it was minus 15 degrees, and
Yeah,
blew
so
my
I've
mind.
experienced down to minus 40 Celsius and hope to not.
Yeah, I've
That's wind chill. That
experienced
was
it.
without wind chill. I've experienced minus 70 with wind chill.
Yeah, I was in Buffalo in the wintertime, and it was minus 40, and it was outrageous. Yeah.
Yeah. Yeah, I was at Michigan State. They actually closed campus because the hospitals were complaining about the number of frostbite students they were getting.
Someone wants to know where the Fluffle Monster is. I can
Oh,
see it
he's
in the here.
actually
I'll just change the there.
there. Do you see him
Yep.
chewing a bone off to the side?
Yeah. Yeah, he's been mollified with some kind of rawhide tube.
Yes. So it's currently 15°C, 58 degrees Fahrenheit inside my house because our boiler went out. So at some point during the show, a boiler repair dude is hopefully going to come and um, make it not so cold in our house.
Good luck. Yeah, yeah. You're wearing like sweatshirts, a lot of layers inside your house.
Yes. Yes.
Okay, so for this last episode, before we're both traveling for a little while, we're going to be talking about the search for life on Mars. So
Yes.
if you have no idea what it is that you've stumbled into, this is a live episode of Astronomy Cast. We cut out the show part that goes on the feed, and then the rest of this is just us being silly. And we will stick around and answer your questions about space and astronomy. I'm going to say hi to some people, though. Hello to Astronomy Cast. Wait, that's us. Carolyn B., Chris Beaver, Cole Morgan, Daniel McCool, Dan Kovu, how do I say it, Dane? Ilad Avron, Giselle Sabarin, Guido Bibra, Helg Berkog, who told us something very cool, which we should probably share, that he's getting his car painted the color of the universe, which I think is awesome. Jim Meeker, John Seffield, Michael Meyer, Mike Brown, Nancy Graziano, Nichols of the Yard, Pamela Gay, hey, Quickie Koala, Ren and C, Space Today, Spunkmeyer, Thomas Traniker, and Valdegast. Welcome, welcome. Mars, where it's even colder than British Columbia.
Today.
Covio. 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 All right. I don't think there's anything else to talk about. My intro's ready to go.
For anyone who's watching this live, next Wednesday night in San Francisco, we're doing a meetup. Just me and CosmoQuest people. Sadly, no Fraser this time. He'll be in Costa Rica where it's warmer with more things trying to kill him.
Yes.
But if you're in San Francisco, I will be there next week, and we're doing a meetup Wednesday night. It's listed on universe.com. Just search for CosmoQuest in San Francisco.
Right on. Okay. I'm ready. Are you ready?
Searching for the record button. I found it.
Okay.
I'm ready.
All right.
I'm pressing record. It's recording. Sadly, no Fraser this time. He'll be in Costa Rica where it's warmer with more things trying to kill him.
Sure.
I'm stopping. Flail.
Okay. All right. Here we go.
Okay. Pressing record. I am recording.
I am also recording. Testing. Yep, I'm good. You good? Okay, here we go. Astronomy Cast, episode 431, Searching for Life on Mars. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing great. This is sort of the last episode, and then we're going to be for a couple of weeks because we're going to be both on various trips. I'm going to be down in Costa Rica, tromping through the jungle looking for insects with my wife.
And I'm going to be in San Francisco at the American Geophysical Union meeting. So yeah, I've got all the science, and you've got all the bugs.
All the bugs, yeah, and pit vipers and all kinds of. There may be monkeys though, so that's going to be all right, and sloths if you've been watching Planet Earth.
And they have the kind of iguanas that live on the beach, and there's a fabulous video floating around of this one amazing iguana, like totally running for its life down the beach of snake death.
Yeah. That's you're talking not about Costa Rica, but about the Planet Earth too. Yeah, that is the greatest piece of nature photography, nature video I think I've ever seen. What an amazing shot! The internet went crazy for that. But that's not what we're talking about today. We are talking about searching for life on Mars. So sure, Enceladus and Europa are all the rage these days, but classic Mars is still a great place to search for life. In fact, ESA's ExoMars is scanning the planet's atmosphere for methane right now, searching for evidence that there might be life there. Let's talk about the search for life on the red planet. All right, well, this is a big, long story. So let's kind of go back to the beginning of when did people really kind of think, hey, there might actually be life on Mars?
Like when they realized it was a planet.
Right.
It's once they had telescopes and were able to resolve that Mars was a disk and Venus was a disk, it started to become the stuff of science fiction that Mars had life, Venus had life, that these worlds that appeared to be not too different from our own were definitely places that we should go and meet the others. And early science fiction is rife with amazing stories of tumbleweeds on Mars. And of course, we've all read about Percival Lowell's canals that he imagined seeing through his telescopes. So as he peered at Mars, you can make out with any perfectly good telescope that has a sufficient eyepiece that Mars has different colors on his surface. And he was able to, using his imagination as well as his intellect, envision all of these different colorations as man-made linear canals or Martian-made linear canals all across the surface of the red planet.
Right, but really it was just an optical illusion, and and none of these things. I mean, I love the imagination that he imagined this dying Martian society where they were trying to use up the last of the water on the planet. They had these big long canals that went from the poles to feed the irrigation canals to feed the cities and feed the final crops, and the planet was dying. And of course that led to some of the other, the science fiction of the time. We think of like John Carter, Warlord of Mars, or the invasion
Martian
from
Chronicles.
No. Oh God, the one where the War of the Worlds,
Oh,
where
yes,
you've got the Martians give up Mars, or they come to Earth looking to kind of expand their territory and deal with their ecological collapse. So, and it turns out that it wasn't Mars that was destroying the environment; it was Earth all along. That's too much science, I guess. Too much reality. So that was sort of the imagination. But when did we sort of start to really look for life on Mars? Like actually practically try to see if there's anything there.
So it actually took being able to get there before we could start rationally looking for life. The early flyby missions were able to go, oh, clearly no big cities. Oh, clearly no big canals. So it was in the 1960s that we ruled out civilizations on the red planet. But hope lives eternal. And so when we sent the Viking missions in the late 70s, the Viking missions had a whole series of experiments on board that allowed them to land on the surface, scoop up samples of the soil, and look experimentally for life as we knew it. And that may be the key is at that point we were looking for life that behaved in ways that we knew how to test for.
But so far all of that searching, nothing, just desert.
Well,
right. So there was no large life forms. There was no trees. There was no cities. There was no canals, irrigation canals, Martian farms. Right. There was just rocks.
No
tumbleweeds. Just rocks and dirt and more rocks, some ice. So I guess the search needed to get more detailed, right? They had to take that exploration to the next level and actually examine really close up.
And so just like in parts of Death Valley, in parts of Antarctica and Arctica, a quick glance around the blasted landscape seems to reveal no signs of life. We hoped that on Mars, that while the landscape appeared to be lifeless, that if you looked a little bit further, just like is true in the poles and the deepest deserts, there would be life there between the grains of dirt.
So, any luck?
No. Well, sort of. We don't know.
We don't know. Yeah.
This is one of the things where the reason I said those answers in the order I said them was our initial analysis of, and by our, I mean the scientists who came before me, because like I was 4.
But we were alive.
We were alive for this.
Yeah, we were like 6. I'm trying to think. It landed in what, 79? 78, 79?
Yeah, 78-ish. And so while they were doing these experiments, we were alive.
Yeah, we existed.
We were not the ones analyzing it. And early analysis was, for the most part, conclusive of no life. But the reason I say for the most part conclusive of no life is there were 3 different experiments that they ran on the Viking missions. And one of them, labeled release, in which they looked for specific gases to be released in a way that would indicate respiration was taking place. That one experiment of the 3 had a null result. It neither said no life nor life. It was simply inconclusive.
Right. So, but the others weren't the others inconclusive, or they thought they had a positive result, but non-biological processes would also provide the same result, right?
It depends on which of them you're looking at. So with the gas exchange was negative. There was just no gas exchange taking place. But then with the gas chromatograph mass spectrometry experiment, they were looking to separate all of the vapors and try and measure organic molecules. And this is one of those cases where the Viking landers heated the compounds, and we now understand that this process might have destroyed any organics that were present. So it appears that what was initially a null result, a negative result, in this case, an initial false no life result, can now get budged into the inconclusive result category.
Right.
So this is where it's like, no, yes, I don't know. We don't know. And what's amazing as journalists is we get to see on a regular basis scientists continuing to analyze and reanalyze this data and find ways to argue both directions, which really says we just need to keep sending robots to Mars until we settle this problem.
Those poor robots. So, I mean, this was actually... I mean, the crazy thing about this is that we still write stories about this on Universe Today, where somebody reanalyzes the results and then takes a stand either way. And so we will have a story on Universe Today that'll be something like, the discovery of life has been confirmed, and then no evidence found in Viking data. The landing date was in 1976. So I was 5. But right, so the powerful life lesson that NASA learned from this is that if you're going to say or going to search for life, and you're going to spend the hundreds of millions, even billions of dollars to send this experiment to the surface of Mars and answer this question, you better get it right.
Yes.
Right? That you would better answer this question to a level that no scientist is going to question the validity of your discovery.
Well, and this gets us to the extraordinary claims require extraordinary evidence argument that we've heard articulated by folks like Carl Sagan when it comes to talking about life on other worlds. And in fact, one of the scholarships I got my senior year of high school was there was a Carl Sagan essay contest to write essays on how you should search Mars for life. And my essay got honorable mention, and it paid for all of my books my first year of college. And so folks have been trying to figure this out, and have been challenging new generations to try and figure this out, because we do have to figure out that extraordinary evidence.
Yeah, exactly. So this was the powerful life lesson that NASA learned, and so the next time that they really started to not search for life, but they sent Spirit and Opportunity, and this was to search for the conditions. I mean, not even like, was there water on Mars, really? And we've done a whole episode on this. So, this is the new tack that NASA went down, which is like, it's not about the search for life; it's the search for the conditions for life first.
And what they're doing is interesting, because just like with the Viking program, Viking had 2 landers, 2 different locations. Ideally, any evidence you find, you want to find it in multiple places. We had 2 rovers, Spirit and Opportunity, and Curiosity just goes wherever the heck it feels like, very slowly. It does it very slowly. So we're searching those multiple locations. Mars 2020 is again going to be a rover capable of searching multiple locations. We are increasing the number of experiments carried per robot, so that hopefully we can, just like we've proved cosmic expansion using multiple lines of evidence from multiple experiments, hopefully when we find life, just like Viking tried to identify it via 3 different routes, hopefully when we do find it, we'll be able to identify it via multiple routes in multiple places.
Right. And so the other sort of complete separate way that researchers are looking for this is, of course, the detection of methane in the atmosphere of Mars. And this is something that was turned up probably a decade ago, but still we're only finally getting the right tool set to be able to do some kind of conclusive analysis and try to get to the bottom of it. So what does it mean that they found methane in the atmosphere of Mars?
So methane, which is a carbon hydrogen molecule, is a molecule that breaks down in sunlight. So you take methane, put a cow in a field, leave it alone, methane will be produced. That methane left alone in sunlight is going to cease to be methane. And so whenever you detect methane, that means that it's something that has been recently produced that isn't a byproduct of formation. And the only 2 things we know that should be producing methane are geologic forces, so volcanoes, things like that, and life processes. So the fact that we see methane on Mars and Titan and other worlds in our solar system indicates that one of 2 things is possible. These worlds are geologically active, or, and this is an and/or, you can actually have both, Earth has both, or there is life. One of these has to be possible. Both of these is possible.
And that's the funny thing is that literally it answers 2 really, or at least it gives us 2 intriguing mysteries that we're trying to solve about Mars. Is there life on Mars? But also, is there volcanic activity on Mars? Both of these are very important questions that we really need to have answered for us. And so the fact that this methane has been discovered in the atmosphere, it may sadly tell us that, it may not be evidence that they're for life, but it may very well be evidence for active volcanism that's still going on to this day, which is kind of amazing and answers all these really important geological questions. So don't feel totally sad if it turns out that there's sulfur in your methane as opposed to the whatever you need for life.
And I feel like I should point out, you can get involved in actually helping with this over at cosmoquest.org, because we have 2 sets of Mars images. The set you're going to look at right now is of the potential Mars 2020 landing site, where we're trying to find areas that have the fewest craters, because that means they're the ones that are getting the most weathering, the most disturbed by environmental factors, which means hopefully any fossilized haven't yet been broken down by ionizing radiation and the sun. Any of those organics will be fresh on the surface. And the other set of images that we have are of the youngest volcanoes on Mars, where we're looking to find areas, again, with the fewest craters, because that indicates where the youngest volcanoes are, so that hopefully we can figure out how recently was there volcanism on Mars.
So if all goes well, when will we get an answer from the ExoMars mission? Like, are we going to be able to find this out in the next months, years? I mean, we're around the corner from it. I mean, it's sensitive enough to answer this question, right?
So ExoMars is sensitive enough to start getting at hints of what kind of volcanism or life is it. So, for instance, if it was one set of origins, we might expect it to be related to the seasons, where perhaps ancient, locked up in the ice methane was getting released during seasonal melts. Or more likely, if it's seasonal, but again, inconclusive, more likely if it's seasonal, it indicates life that comes awake when it's warmer and then goes back into hibernation when it's colder. What we're currently actually finding is the Mars methane appears to not be seasonal. And not seasonal means either, again, inconclusive, that you have life that is perfectly happy to be frozen, or you have some sort of outgassing that happens year round and isn't tied to melt and geologic processes usually this isn't conclusive again, aren't tied to seasons. We do find that volcanoes are more likely to be unhappy during major seasonal changes in the amount of snow on them. Iceland experiences this on a regular basis. Different situation.
So, okay, so we're still gathering the data, and I guess it's not going to be one of those just slam dunk things like unless someone sees a fossil, big fossilized dinosaur, big fossilized salmon on the side of a crater on Mars, like you're just not going to have that conclusive evidence. Instead, really, at this point, what kind of life are we talking about? If we were to sort of look at it in the lab, what would we imagine this is?
So what is most likely on Mars is some sort of an extremophile. So to give you a for instance, on Earth we have this creature. It is named in Latin, and I'm going to mispronounce it. It's Denococcus radiodurans, I think. I last took Latin in 8th grade. But this particular critter is perfectly happy to live through blasts of radiation that make the surface of Mars look friendly, and it's happy to live through complete vacuum and icy cold. This is the critter that does not want to die. So these kinds of, not in this case, it's not single-celled, but these little tiny walled bacterium, this is perhaps the most advanced that we could hope for, is a bacteria with a few cells that you need a microscope to find. It would be fabulous if we happened to find trilobites fossilized on the side of one of these dried out river basins, but I'm not holding my breath. We have had, again, in the land of inconclusive with lots of argument, nanobacteria, potentially, but probably not, stress on the probably not, found in Mars meteorites. When you hit Mars hard enough with an asteroid, it throws chunks of Mars at escape velocities off the surface of Mars, and occasionally they make it all the way to the planet Earth, where we pick them up. And scientists then look at them under microscopes. And back when I was in grad school, there was a researcher by the name of Hill who looked at a coated meteorite slice underneath a scanning microscope and saw what he thought might be nanobacteria, similar to what are seen and debated about at places like Yellowstone. But there are those who claim that it was simply a bad coating. There are those saying that it's just weird mineralogy, and no one has been able to find similar samples in other rocks.
Is this the Allen Hills meteorite? The one like back in I'm trying to remember, it was like 1998 or something like that, where Clinton announced,
when I was in grad school.
Yeah, Clinton announced the discovery of life on Mars. But I mean, the amazing science on that is that they have this meteorite and they're able to cut it open and sample the gases inside the cracks of the rock of the meteorite, and they are identical to the atmosphere on Mars. And no one disputes that science. Like, this rock,
we know it's a Mars rock,
definitely came from Mars, which I think that alone is an amazing piece of science to know that. And then the question, I guess, is, did the life remnants that was found, fossilized life, or did that get in from Earth? Did it contaminate? So this is the problem, right? If we ever find these meteorites on Earth, there's always going to be this question of contamination.
Well, and like I said, with this one, we don't even know if it's actually nanobacteria, because they did have to coat this slice so that they could use it in the microscope. Certain samples, you coat them with films with, it's usually a single atom layer thick coating of gold. And if you sputter that on wrong, it looks like nanobacteria. So we don't even know if they actually saw something or if they screwed up in the prep of the sample.
Right. and if the sample was contaminated by sneaky Earth life. So,
Yeah.
uh, so so where we stand right now, the next big mission that's on its way to Mars is the Mars 2020 rover. This is going to be the follow-up of the Curiosity rover. It's going to look identical to all intents and purposes to Curiosity, but it's going to have a very different payload. It is going to be a mobile life-searching laboratory. It's going to have all those instruments that we were all like, why can't Curiosity just use its microscope to find life? Why can't Spirit and Opportunity look for fossils? That this is the machine that's going to fulfill almost all our dreams. I love the idea that it's going to have scoopers. It's going to find scoops of samples. It's going to drop them into this like oven on it. It's going to perform very similar experiments to the kinds of things that the old Viking landers did, and then poop these out on the surface of Mars as it moves along. And it's got some number of experiment bags that it can do. So this is it, right? We are going to finally, hopefully, have our best crack at finding life right there on the surface of Mars.
So the way NASA frames it is the science instruments are state-of-the-art tools for acquiring information about geology, easy and safe, atmosphere, easy and safe, environmental conditions, we know how to do that. And then the last one is potential biosignatures. And like I said, we're looking to send it to the places on Mars where you have the freshest soil. So this is sort of like going to the beach and sweeping away the top layer of dirt and getting to the wet soil underneath and being able to occasionally find critters there. Well, we're probably not going to find clams staring up at us, but we might find those extremophiles. And if not, we might at least find the organic molecules that haven't yet been, and this is far more likely, folks, there is the potential at a better chance than anywhere else we've gone so far to find organics that haven't yet been broken apart through ionizing radiation and ultraviolet light from the sun.
Yeah. And then if that goes well, or if it's inconclusive, the next step is some kind of sample return. And so that is something that Europe has been working on. That's something that NASA is considering, and that will be probably within another few years after that, is to, that one of the jobs that the 2020 rover is going to do is gather up samples that then some future mission may retrieve back to Earth.
And this is the cool idea, is this thing is basically going to be carrying rocks around in hopes, according to some talks I've seen, in hopes of some future mission landing, and there's basically a handoff of samples. And this is really that ground truth that scientists talk about so much. It's one thing to have a rock that got hurled at us by Mars, but we don't know where on Mars that rock came from. It's the same issue with lunar meteorites. But when we went to the moon and we said, and this rock is from the Sea of Tranquility, and this rock is by over near Hadley Rill, and this rock is, we could say exactly what parts of the surface the rocks came from. We could use various forms of radio dating to be able to get at the histories of these surfaces. And suddenly we could take our laboratory science and use it to calibrate the crater counts we'd been doing, the spectral returns that we'd been getting from reflected sunlight. We want to do that with Mars. We really want to do that with Mars. And we just need something to send the rocks back to us.
Yeah, absolutely. So where we stand right now, in conclusion, the search for life for Mars. Do we know if there's life on Mars?
Nope.
No. We We know that, but we're so close. We know that Mars was wet for long periods of time in the past. We can see with multiple lines of evidence that there's like these great little blueberries. There's different kinds of olivine and other compounds. There are
Olivine formed in water, other molecules formed in water.
one of the most compelling discoveries that was made by Curiosity, I think, was this what looks like a bacterial mat on the surface of Mars. I don't know if you saw this research. It saw on the side of a crater like what looks like a deposit, like a sediment deposit, but it's of life over some long period of time. And we have these on Earth, so it could very well be that that's the case. We have this evidence from the atmosphere of methane. We're still not sure of the source. So
And the problem that we have is everything we've seen so far has more than one explanation.
yes.
And not life is the more, it's Occam's razor is the no life answer. There is nothing conclusively ruling out life, and there is not extraordinary evidence that there is life. So there's room for hope, there's room for doubt, and people will be arguing over their beers for, unfortunately, a long time to come.
Yeah, absolutely. So stay tuned. As soon as life is discovered, I promise we will let you know. Thanks a lot, Pamela.
Thank you, Fraser. And now we save.
Save. That's 431, I said. Yeah.
Yep.
Okay. Chad had to do some surgery on the last episode.
Yeah, did you have a chance to listen to that?
Not yet.
Okay.
What?
What's it doing?
Oh, I exported. Okay, I see my problem. I exported before I saved.
Oh.
Okay.
My dog has never been so happy as with chew I have given it.
Yeah, you've really tied up that dog. Okay, I think we're good. I think my episode is safe. I won't feed it into the machine yet. Okay, I won't upload it to Dropbox. I've got a couple of questions now. So let's see. This isn't a question, but PsychoCat 749 said, Fraser, it's true. Rick and Morty is awesome, and you should totally watch it. PsychoCat 749 agrees with me, Pamela. Rick and Morty.
I did watch a couple of episodes.
Good. Did you get to the Meeseeks? Meeseeks and Destroy?
No.
That's like episode 4. Oh, it's so good.
Yeah, I think I watched 1 and 2 so far.
Are you uploading your video?
I might be.
Yeah, your quality is gone.
Stopping that.
Yeah. I could see it.
Okay, it's now paused.
A couple more questions. Michael Meyer wants to know, does anybody know what payload Red Dragon will take to Mars in 2018? No, we don't know yet. No. The first time they launched with the Dragon, they took cheese. So that would be good. But no, I would assume that whatever they launch, they're going to try and make it practical in that things like, obviously cheese is practical. Who doesn't love cheese? And, Martian explorers would love cheese. But I think the thing that'll be most useful will be like some tests of refueling, and then
The
various
fuel factory.
Yeah, fuel factories, that kind of thing, just to start really practicing and testing out that, because having a way to get back, generate fuel, oxygen, water, things like that on the surface of Mars.
I think they should take tilapia.
Take tilapia.
They're not asking me, but I think they should take tilapia.
Yeah. John Suffel asks, was the events of the previous episode the most catastrophic thing to happen to Astronomy Cast or Weekly Space Hangout?
No.
No.
We've lost all of the episode.
Yeah. We've had ones where we forgot to, or like we lost the recording. And so we recorded the whole show, lost the recording, and then had to record again. So
Yeah.
that's the worst, is where you've
Yeah.
done the whole show. In this case, we just picked up where we left off and just took a little extra editing from Chad, and it's fine. So no, that was fine. We also had the episode where we did it again. So we finished the episode and we
Yes.
went, "This is
We
garbage."
hated it.
Yeah, we hated it, and so but we had learned how to talk about the topic, and so we went back and did it again.
Yeah.
That was the episode on supersymmetry, I think, which was literally us trying to figure out a way to even understand and explain it to each other. So that episode
Yeah.
just went in the garbage, and you'll never hear it. I don't think we have it. I think we just literally just
Sometimes you just have to do that.
yeah. I have done. Oh, so we just did. I don't know if you saw, listeners. You probably didn't see it, Pamela, but we did our episode of the Guide to Space on my YouTube channel, and we did colonizing the solar system. Did a collaboration with Isaac Arthur. It's wonderful. It is, each half is 20 minutes long, so it's this really an hour-long television show about colonizing the entire solar system. So my check was 20 minutes long. We did the whole episode, got right to the end, and realized that my focus, our battery had crapped out, and so we sort of pulled the camera out, put in the new battery, put it back in, but didn't get the focus right and didn't remember to go back and fix it. So we did the whole 20-minute episode and then realized the focus was garbage. So we did the whole episode again. So if you watch that episode, my voice is going, and I wasn't really trying to. I wasn't sort of at the top of my game. I was spent, and so I was just my performance was not so good. So that was pretty funny.
That's kind of hilarious.
Yeah.
Now, I have to point out that folks over on the YouTube are talking about horse-sized termites creating Olympic mons, and I'm pretty sure we would have seen fossils from that already, but I just like the imagery involved. I now want to see Olympus Mons fanfic with termite horses.
Cole Morgan is asking, how precisely are spacecraft weighed before launch? Are different types weighed with different precision? At what points do fractions of a gram become insignificant for calculating the trajectory in orbit? Oh, they know the weight of those to the gram, for sure. I mean,
grams are pretty big, aren't they?
Yeah. Grams are big.
So the question is, what fraction of a gram do they know it to? And that I don't know.
No, I don't know. But the amount of, the amazing part about this is when they're doing, the orbital burns, the trajectory, they know how, what angle they're pointing at. They know they're firing for X amount of seconds.
Yeah.
And then they sometimes make a couple of corrections as they go. And that's, in some cases it's fully anticipated. Other times it's just because they didn't quite get on their trajectory. And so they're in a new location and they have to fix it. So no, they know very precisely. It's a good question though. I wonder. I love that you had the two question marks. You have the one with the, I don't know if you can see it.
Hollow and
one was
filled
hollow and one was filled.
Yeah.
Yeah, I don't think anyone's ever found those two question marks before. Thomas Tranker wants to be a bungalow farmer on Mars. Do you get the reference on that?
No.
Futurama.
Okay. That one I should know.
Yeah, it's the one where they're on Mars and Amy's father is a bungalow farmer, and so they. Let's see. There was some other. It's the new fan fiction, Attack of the Killer Termites. Would a tardigrade be able to live on Mars? This comes from William Satterthwaite.
It would be able to not die on Mars. So
right, it would thrive.
Difference. Yeah. I don't know if it could reproduce or any of that in the briny water that does exist on Mars in the subsurface areas, but simply being exposed to Mars atmosphere would not be automatic death to a tardigrade.
Yeah. Okay. This is a good question. Michael Meyer asks, so the results from ExoMars kept private by ESA like those from Rosetta?
I don't know.
Rosetta. Just for people who don't know about this, there was all of the pictures that you saw from most of the mission coming out of Rosetta were coming out of the nav cam because those were freely available by from ESA and from the scientists that built the instruments. The really fancy images from Rosetta were held back so the scientists could do their work first before releasing it to the public, and that always rubbed me the wrong way.
Proprietary period is the fancy set of words for that.
I don't like it. Sam wants to know, why is there no magnetic shield on Mars?
Because there isn't an active core that is generating a magnetic field. So you need to have what's called a magnetic dynamo. This is basically some sort of spinning, ionized, free electrons. Basically, if you have charge that you move, moving charge generates a magnetic field. In order to have moving charge generating a magnetic field, you need to ionize. And so this means that you need to have a system where the electrons are getting separated from the atoms that they'd normally be happily creating as neutral. Earth, sun, they all have various molten levels of hot stuff that has these ions, these free electrons that are moving and able to generate these magnetic fields, and Mars just doesn't have that.
Yeah. Physics Police wants to know, how would the day-night temperature vary if you tented over the moon and filled it with 100 meters of Earth-like atmosphere? That takes some math.
I don't know.
Yeah, I don't know.
100 Earth atmospheres?
100 meters of Earth-like atmosphere, right? So if you just like covered it in a big balloon, and then so you tented over all of Mars, so you could keep the atmosphere in then. But I don't know how would the temperature change, because I mean it's got that big long orbit. It's got 28 days. It's got 14 days of daytime and then 14 days of nighttime, depending on where you are on the moon.
Yeah.
And then, but it's surrounded, and so it's like acting.
So
the atmosphere is going to insulate, right?
So the question is that balloon shell, what is it made of, and what are its thermal properties? Because if it allows ready transmission of infrared radiation outwards, then the heat would get radiated. It all depends on what the shell is made of.
Like a car, like the way a car heats up because it traps the infrared radiation inside the car, right? Okay. Yeah. So I guess that's the question: is what is the bubble material made of? Does it transmit infrared, and then how much? So then, in theory, could you dial it in? Could you dial in the right material, assuming you could find some kind of transparent, you could put some kind of material into the transparent material to sort of dial in the amount of infrared that captures it, right?
So ideally what you would want is a double layer that has a vacuum gap between the two layers, of a surface that you can change the properties of. So there's various windows and stuff nowadays made out of special dielectric materials that you can actually change the opacity. Now you can imagine if you could change the opacity as a function of wavelength so that it consistently never lets the IR radiation out, but then gets more extreme in what it doesn't let out once you hit that nighttime. You should be able to keep yourself fairly well insulated. But like I said, it would require this air gap, and you'd essentially have to have a mirrored surface across all the different wavelengths that heat likes to escape at. So block all the black bodies from doing their black body radiative transfer thing.
Of course, the thing that's most important is that if you could build such a bubble, then you could put on a pair of wings and you could fly around in the surface of around the moon, which would be awesome.
It's true.
Yeah. So we really need to get on that, I think. Of course, if you just like took atmosphere, Earth-type atmosphere, and just fed it to the moon, it would last for a couple of thousand years. So you could terraform the atmosphere of the moon for a few thousand years, and then the solar wind would blow away all the atmosphere because the gravity on the moon just isn't high enough to hang on to it for very long. So
I wouldn't have guessed that it would have stayed that
It would
long.
last
That's
that long.
kind of
Yeah,
cool.
yeah. Someone did the math, and I reported on that a couple of years ago about
This is cool.
a couple of thousand years. So you would have to constantly replenish the atmosphere on the moon,
Yeah.
but you could literally just smash a bunch of comets into it or whatever it would take, feed it an atmosphere, and then just keep it replenished. But I think domes are better. Domes or enclosing the entire moon in a sphere. Just
I'm
preserve it.
I have so there's some really deep craters. Just take yourself a crater, use the crater walls to your advantage and dome that
Yeah.
already very deep crater.
Yeah, they did that in 70s where some people, I'm not going to try and spoil it too much, used a chasm on the moon and stay at the bottom of the moon, and that protects you from the radiation, which is amazing, right? Like, you're so worried about the radiation on the out of being in space, but if you can get down to the bottom of one of these, just a crack, a valley, none of the radiation from the sun is going to hit you. It's all just going to get absorbed, and very little of the cosmic radiation is going to hit you, and so you're largely safe from the greatest problem. And this is going to be the same solution on Mars. You go to the bottom of some valley, as long as you're shaded from the sun and you've got enough crater wall above you, you're going to be able to cut off that radiation risk significantly.
And I just want to clarify for people who misheard you the way I initially did. You said in the 7 eves, not in the 70s. They
No.
didn't do this in
Back
the 70s.
in the 70s, they colonized the moon. No, 7 eves. Yeah.
It's an excellent book that everyone needs to go read right now.
Yeah. Well, the first half.
Yeah,
People argue
the
about the
first-
second half.
the first 2/3.
Yeah. Let's see. So, BK Nesheim asks, will there be liquid water down in the rocks on Mars?
There's briny water.
Under the surface.
Yeah, super, super salinated. So lots and lots of salt. And it's the high salt concentration that allows it to exist in the very low atmospheric pressure.
Yeah. Why does this keep happening to me?
What is happening
There.
to
The Slack chat just keeps changing its size. I'm not really entirely sure why, so I just made it bigger. Let's see. More questions. Hit me more questions, or we're done. That wasn't a threat. That was just like. So William follows up with his previous question: can the non-active core rule out active volcanoes for methane, or the uncertainty is too high? So I guess the question is, like
that's what we thought. We thought from all of our mathematical modeling, because it's small and doesn't have a magnetic field, that the sucker had cooled off. But science likes to do things that we hadn't anticipated. This is why we keep exploring our solar system, world, under the oceans, across the universe, is there keeps being new things that we don't know. So there could be a partially liquid core instead of a completely solid core. There could be pocket. We don't know.
Yeah.
Partially liquid is or not fully solid yet is I think how they actually phrase it, is what I've heard the most often.
Yeah. I mean, it's possible that, for example, Olympus Mons could have erupted last within a few million years. And,
Yeah.
Planetary geologists still aren't sure if it's not still active and could even erupt again in a few million years. So I think, these are all the kinds of questions that they still really need to get at, is just how active. And this is, I think, the 2020, there's going to be another one that's coming up that's going to have a better chance at determining the seismology. Oh, right. Schiaparelli was, I think, supposed to Was it going to be
Yeah, it
looking
kind of
for?
bit the dust.
Yeah, I don't know if it had. Did it have some kind of like geological search on it? I'm not sure. Anyway, so
Yeah.
this is one of the questions that still we still need to get to the bottom of is just how geologically active is Mars? And so the methane search may tell us that in fact it is still fairly active. But we know from the lack of global magnetic field that it doesn't have the dynamo going. But it does have
Yeah.
pockets of magnetism that could be like just coming out of the rock, or it could be, that there
And
is
we
still
see that on the moon.
yeah, yeah. So that's what we're still sort of looking at. There was a question that just came in from Dane Coveu. Have we found large caves on Mars that we could enclose and live in?
Yes.
Yes. And
And
how?
on the topic of horse-sized termites making Olympic mines, we just had the comment, why would it erupt if it was built by termites?
Yeah.
I really want to see this fan fiction created.
Yeah.
I
Yeah.
really want to see this fan fiction.
So yes, lava tubes. So there are lava tubes on Mars. We've actually, if you do a Google search for lava tubes Mars, there's these great images of like the surface of Mars and then this black dot.
We call them
And
skylights.
skylights, yeah, and it is the collapsed ceiling to a big lava tube underneath, and so we could land right beside these skylights, rappel down inside, and set up shop, and you would be safe from the radiation.
Yeah.
Not from the low gravity though, so that's still a problem.
Yes.
We had a question here. We got a couple questions here. Okay, there you go. So have we ruled out white holes?
Yes. Well, white holes sort of ruled themselves out. Wait, I'm thinking of wormholes.
Yeah.
I have to look up what a white hole is.
A white hole is, remember, the mathematical possibility that if you have zero mass in a black hole, you get a white hole. It's sort of one of the implications of a zero mass black hole. Einstein, I forget who else did it. But anyway, the gist is, but the minute you put anything in it, the thing collapses mathematically.
Well, wormholes do that.
Well, yeah, but wormholes are sort of are similar but different. But I did actually a video on white holes.
Okay.
So, yeah, if you go do a search for what are white holes, you might get my video on YouTube, and I answer it. The interesting thing about it is that it's possible that we could see explosions out in the universe that might be white holes collapsing. But most likely that they're literally a mathematical. It's just a quirk of the mathematics, not that there's any prediction that these things exist.
Yeah, and I tend to avoid reading about things that you can't observe. So
Yeah,
we
exactly.
keep finding holes in my knowledge about
Yeah.
non-existent
Yeah.
holes. So the idea was put forward by Novikov in 1964, and it extends Einstein's field equations, but it's not something that's actually required to exist.
Yurko, Roberto, if we don't find any life for, say, 50 years, would it be okay to start sending life there? How long before we can stop worrying about the contamination of existing life? That's a great question. When is it okay for us to give up on searching for life and start infecting Mars with our own life?
So I think we need to have done some sort of a thorough global survey. And I mean, if we search Gale Crater for 50 years, that isn't sufficient. But so to just pull out the idea I put forward in high school, because since then I've actually seen lots of other people with similar ideas that were far more advanced from what I did in high school, but same idea. If we went and landed a fleet of things in a grid pattern, the Russians put this idea forward for exploring Venus with basically sending a whole bunch of lawn darts, and instead of lawn darts which just are basically weather stations, you instead sent a whole bunch of single experiment things that land all over the place, relay back their experiment results. If you do that sort of systematic whole world checking for life, then I think you start to be able to say, yes, we can invade.
Right. Well, we're going to invade no matter what.
It's true. We're
Right?
horrible.
Yeah.
Humanity is horrible.
Yeah. We are going to pollute that planet, and we are going to make it our own world. And that is just, there is no way that's not going to happen.
I'm just going to sit here and angrily drink my tea.
Sure. So it doesn't matter. I mean, and I think that we will really have a very serious ethical dilemma here, where we, if we know that there are microbial Martian life forms happily chewing away in the soil, we are going to definitely, it doesn't matter. We're going to be infecting it and we're going to be ruining it, and that's just kind of how we operate. So, okay. Right. So someone was wondering some information about New Horizons, and Nancy said, by the way, February 10th episode of the Weekly Space Hangout, we're going to have, I don't know, someone from New Horizons, some kind of director of the New Horizons mission on the Weekly Space Hangout. So come back on February 10th, and we'll be getting all the information from New Horizons.
What's cool is they're trying to plan their encounter, not knowing if it's a single object or a binary object. And it's fun watching the young scientists who are doing a lot of the calculations, basically going, blah.
Yeah, I can't wait till we get some, the next object that New Horizons flies past and some of the closer flybys.
It's going to be like a several pixel blob. So nothing exciting. Just set expectations.
All right, let's wrap things up. This is, as I said, the last you're going to hear from us until the 23rd of December, when both of us are back from our various journeys. If you want to follow what I'm going to be doing, I would recommend you follow my wife's Instagram channel, which is Carla Thompson with a K, because we're going to be taking pictures of bugs. And I'll bet I'll be featured in her Instagram story. So that's on Instagram. I recommend that's the place you follow that. I'm F. Cain, of course, on Instagram. I'll try and post a bunch of stuff. You're going to be in San Francisco.
I will be at the American Geophysical Union meeting. So I will be either tweeting as CosmoQuest or as myself, Starstrider. So follow along. It's going to be a whole lot of boring meetings for me, so I may not have much to say other than, wow, just spent 12 hours in boring meetings. So follow his wife.
Yeah. And we're going to be hopefully getting lots of crazy critters, mostly bugs. So it'll be all bugs. Yeah. Okay. Well, we'll see you all in a couple of weeks. Pamela, have a great trip. I hope I don't die. All right. We'll see y'all later. I'm going to stop the stream.